Let's sum up what we learned in the lab about Newton's law. So we saw a few relationships. When we have an unbalanced force on an object, it accelerates in the direction of the unbalanced force. But we also notice that something happens when we change that unbalanced force. The acceleration also changes. And also when we change the mass, that acceleration changes as well. So if we double the force, the unbalanced force, but keep the same mass, what happens to A is that it also doubles. So A is proportional to the unbalanced force. On the other hand, if I keep that unbalanced force the same, but I double the mass, my acceleration doesn't double. It actually is one half. It decreases. The higher the mass of an object is, then the less it accelerates with the same amount of force. Which makes sense. If you have a heavy object, it's going to take more force to accelerate it. So we know that intuitively from our everyday experience. So these relationships we actually can write in a formula or an equation. You actually found those equations when you did the lab. So let's just write down those two main relationships. As the unbalanced force increases, acceleration also increases, and by the same amount. And the second relationship is as the mass increases, acceleration decreases. And that also happens by the same amount. So for that first relationship, we say that that acceleration is proportional to the unbalanced force. And we can use the Greek letter alpha to represent that proportionality. So that Greek letter alpha means is proportional to. If you have two variables or two quantities that are proportional, we get a linear relationship. As one increases, the other increases by the same amount, which is what we saw in the lab. So if I doubled A, well, actually, that was our dependent variable. So we would double our unbalanced force, then the acceleration would also double. If I tripled my unbalanced force, the acceleration would also triple because they are directly related. They're proportional to each other. So as one increases, the other increases by the same factor. And similarly, if I say I halved my force, then the acceleration would be one half. Or if I took a third of the force, the acceleration would be one third as well. Mass is different though. As my mass increases, the acceleration actually decreases by the same factor. So if my mass doubles, my acceleration is a half. If my mass triples, my acceleration is a third. We say this is an inverse proportionality. So I still use its proportional sign, but I say it's proportional to 1 over the mass because if I doubled this, I would get 1 over. But what actually would happen is we would change our mass. So if mass is 1/2, acceleration is doubled. And vice versa, if I doubled mass, acceleration would be 1/2. If I tripled mass, acceleration would be 1/3. So whatever is happening to one variable, the inverse happens to the other. I'm not going to go into too much detail on inverse proportionality, but it is a curve. It is the curve that you saw in your lab in that first question, and it is asymptotic. So it actually doesn't touch, um, it doesn't touch the y-axis. If I had zero mass, I would have infinite acceleration. So these are actually, we can put these together. So we know that acceleration is proportional to the force divided by the mass. I'm actually going to do that on a fresh sheet. And from our equation that we did in, um, in the lab, we learned that um, acceleration is actually equal to the unbalanced force over mass. So that if I plotted acceleration as my y, let me just do that and I'll erase it. If I put this, if this is my y and this was my x, then my slope would be 1 over mass. What I have to multiply my x by to get the equation would be 1 over mass. And if I plotted 1 over mass as my x, and my a is my y, acceleration is y, then the slope was my unbalanced force. This is a very important relationship. This is Newton's second law in the mathematical form. And it tells us how an object behaves when it has an unbalanced force acting on it. If an unbalanced force is acting on an object, it will accelerate in the direction of the unbalanced force. So we can see from our vectors that our acceleration and unbalanced force will be in the same direction. And it is accelerating directly proportional to the magnitude of that unbalanced force, but inversely proportional to the mass. So we'll just write that down as Newton's second law. This is the mathematical version that we will be using a lot. I'll put it on our formula sheet. And just to note that the units here are newtons and mass is in kilograms, and acceleration is meters per second squared. So newtons are equivalent to those kilograms per meters per second times meters per second squared.